The $190 billion infrastructure wall. Alphabet is on track to spend $190 billion on capital expenditures in 2026, and nearly 40% of that is disappearing into the physical footprint of data centers. While the press releases frame molecular storage as a scientific curiosity, the spreadsheet tells a different story about the looming death of the silicon-based business model. Traditional magnetic tape and flash storage are hitting a density ceiling, just as artificial intelligence training demands have tripled data ingestion rates. For the analyst, the move to DNA storage is not about biology. It is an aggressive accounting move to solve the depreciation crisis of hardware that wears out every 5 years. Molecular storage promises a media life of centuries, effectively removing the recurring replacement cycle from the long-term balance sheet. This is a survival strategy for a company that can no longer afford to rebuild its physical world every decade. The real unit economics of synthesis. The primary barrier to moving beyond silicon is the current cost of writing data, which still hovers near $1,000 per terabyte, according to May 2026 industry benchmarks. While sequencing or reading DNA has become trivial and cheap, the synthesis process is the bottleneck that management rarely discusses in detail. Alphabet's strategy relies on the industrialization of enzymatic synthesis to bring that write cost down by 2 orders of magnitude before 2028. We are seeing a shift in the vendor landscape, where Twist Bioscience recently spun off its storage division into Atlas Data Storage to isolate the high-burn R&D from its profitable genomics business. If Alphabet cannot solve the synthesis throughput problem, molecular storage remains an expensive museum piece rather than a viable Tier 4 archival solution. The numbers suggest they are betting on the supply chain finally catching up to the theoretical density. The hidden Opex shift. Current data centers are essentially massive heaters that require constant electricity just to keep data from degrading. Molecular storage is the ultimate play for a zero-power archive because DNA does not require a cooling jacket once it is synthesized and dried. In the May 2026 Storage and Computing with DNA conference in Rome, industry operators highlighted that the real margin gain comes from cutting the electricity bill of cold storage by 99%. By moving petabytes of inactive training data into molecular vials, Alphabet can reallocate its power budget to high-margin inference chips. Think of it as a massive OPEX to CAPEX flip. They are trading a high monthly power bill for a one-time high-cost write event. This moves the financial risk from volatile energy markets to the predictable cost curves of synthetic biology. The signal under the noise. DNA storage is not a technical experiment, but a strategic effort to de-risk Alphabet's balance sheet from the physical limits of silicon and the soaring costs of the power grid. By combining the infrastructure spend seen in the 2026 capital budget with the recent industrialization of synthesis tools, it is clear that Alphabet is preparing to transition its archival layer from a maintenance-heavy liability to a permanent capital asset. This move targets the massive volumes of cold data that AI models need for long-term memory, but cannot afford to keep on spinning disks. For the operator and investor, the narrative of biological wonder is just cover for a hard-nosed push to fix the crumbling unit economics of the hyperscale data center. The real indicator of success will not be a lab breakthrough, but the first appearance of a molecular archival tier in the Google Cloud pricing console. Watch the Q3 earnings for any mention of integrated molecular storage trials with early access enterprise customers. Subscribe for more